Testing the optical cable network. So we are going into OTDR mode and selecting auto and pressing the scan button. So as observed, end of fiber is got at 2539 meters. However, we also see that the cable is present over here. That means because the 50 nanosecond pulse has a limited energy, the energy being, I will just display the energy on the cursor. So we press cursor once, cursor A will come. We press cursor again, cursor B will get active. Whichever cursor is active is the blinking cursor. So we will press cursor again to make A active. Now A is active. We will use the left arrow button, and we'll bring it towards the end of the first pulse, which is the incident pulse. As we can see, the power over here is 9.4 dB, and the power at cursor B is 7.1 dB, and the loss is around 2.2 dB. However, the loss in the event at the end of fiber is 1.8 dB. So out of the 2.7 dB, 2.2 dB, 1.8 dB is gone here. So only 0.5 dB losses here. So because of this, the amount of fiber it can trace further will get reduced. So now I will use the zoom button to see up till where it has gone. I will use the zoom button, zoom enabled. If you press zoom once, it is horizontal. If you press zoom once, it is vertical. So we come back to horizontal zoom, press the down arrow button. As we can see, I am pressing the cursor again. As we can see that the cursor is, we can bring the cursor up till 8 kilometers. This is where the signal dies completely and cannot trace further. Hence, the last reflective event is considered as the end of fiber. So now, if you want to change this and if you want to change further, we have to go to manual mode. Now we are checking the same fiber at 100 nanoseconds for a 20 kilometer range. Please note, we have kept the averaging at 16K. 16K averaging will enable the equipment to work faster because of lesser averaging. Higher the mode, that is higher the averaging of 32K, 64K, the equipment will take more time to analyze. So now again we will zoom. Okay. Now at 50 nanoseconds, where the signal died off at 8 kilometers, at 100 nanoseconds the signal dies at 12 kilometers. So as you can observe, with every increasing amount of energy, we are able to increase the length of the fiber in tracing. So now we will go to the next pulse width. So the best way to now confirm it, instead of 100, go to 1 microsecond. Mind you, the minute you use a higher pulse width, the dead zone of the equipment increases. The dead zone of the equipment is basically the area or the distance where it cannot find out a fault. So if the initial dead zone is there, there is also something called as the event dead zone. So here now we will check 1 microsecond at a 20 kilometer range. So when you do a 20 kilometer range and 1 microsecond, we are giving a higher energy compared to 1 microsecond. Okay, so now what we are observing? We are observing when you press the cursor here, cursor A will come alive, cursor B will come alive. Now cursor A, I am keeping it to the left over here. Now at the end of the, because of the initial dead zone, this entire, the sensor gets saturated over here, as you can observe. That is why for a shorter distance, you have to always use a shorter pulse width. Only when your ranges are more, only then do you use a higher pulse width, because with higher pulse width comes higher dead zone. Now at cursor A, you have 15.47 dB of power. Now cursor B, if you can observe till here, almost till 20, you are not getting any major event as such. And now the loss in the distance of around from A to B is around 15 kilometers, and the loss is around 5.2 dB. So technically for 1310 nanometers, the loss per kilometer is 0.3 dB. So for 15 kilometers, 15 into 0.3, that is 4.5 dB is the theoretical minimum loss that has to be there, and it is inherent in the cable. However, we can see that it is around 5.27, which is slightly more than the theoretical and still considered good. So now, because there is no event and we are not seeing the noise over here, we can assume that the distance of 20 kilometers is, the range is now less. The power is sufficient, but now the range is less. So now what we will do, we will now increase the range from 20 to 50 kilometers and now see if the pulse width is enough.